Hello, everyone. Thank you for having me here. Today, I want to share with you the latest advancement of our project based on the use of a new polymeric derivative of inulin, natural polysaccharide, to build up nanosystems for anti-cancer drug delivery. As you already know, one of the most important features of this nanoparticle for drug delivery is not to be recognized when administered as non-self, to survive and long circulate to reach the target site. And this is possible thanks to the coverage of this nanosystem with an hydrophilic shell, with guarantee no opsonization and avoid phagocytosis, prevent aggregation, and allow long circulation of the systems. The gold standard for coverage with hydrophilic shell nanosystem is polyethylene glycol, which is actually as a synthetic polymer, very cheap, and represent the gold standard is the most used one. The experience in last decades in the clinical practice teach us how PEG has problem of immunogenic induction in humans. And this is increasing from 1984 to 2016. You can see in the slide how much the population is subject to this EGM production, anti-PEG EGM production. So the emerging challenge is to find PEG alternative to avoid the nanosystem to be sequestrated and cleared by the blood in an accelerated way. So our question is inulin a natural functionalizable polyethylene glycol alternative? To start answering this question, we synthesized the first inulin polylactic acid copolymer. It's a family of copolymers, of 4 copolymers, and they have a different degree of functionalization of grafting by PLA. And the PLA we are using is of 2 different molecular weight. We immediately noticed how this copolymer has interesting properties compared to inulin alone, the native inulin, because the solvophilicity in aqueous and organic solvent is much increased, and the polymer is not anymore a crystalline, semi-crystalline one, but is completely amorphous. And we found out that all these derivatives are able to self-assemble in water and form these nanoparticles with a minimum concentration aggregation, very low, which is a symptom of the good stability of the nanoparticle upon dilution. By merging results of NMR analysis and dynamic light scattering analysis, we were able also to characterize the structure of these nanoassemblies. And we found out that we are dealing with a clear-cut system, so where the shell is less thicker than the core. And we also now know that the behavior of the polymeric shell changes upon the density of inulin on the surface of the nanoparticles. And this is a common behavior with polyethylene glycol, because also polyethylene glycol, when is less dense on the surface, contract in a conformation, mushroom conformation. We don't know if inulin, the conformation of inulin can be defined as mushroom conformation, but it's contracted as well. When the density is higher, we have in front of us a distended, expanded shell thickness. This is a consequence of the distension of the inulin chains. Actually, from this merging all this data, we also know that the core is not completely segregated in the nanoparticle inner part, but there is an interface where PLA and inulin coexist. We tried to encapsulate firstly doxorubicin as a model anti-cancer drug, and we obtained good results. But we discovered also that changing the method of preparation of the nanoparticles, a different morphology can be obtained, and the system can switch from a polymerosome to a core shell nanoparticle, changing from a film rehydration method to a nanoprecipitation. And this is because the different method has a different kinetic of growth of these nanoparticles, and the difference is also in the core-corona ratio of these copolymers. The systems were compared with polyethylene glycol polylactic acid, having the same core-corona ratio of one of our INU-PLA. And we found out that the systems are able to incorporate the same loading amount of doxorubicin. They have a similar size, but the difference is that after freeze drying and redispersion, inulin-based nanoparticles are much more colloidally stable, and they maintain mostly the same size as the sample before freeze drying, while the state of polyethylene glycol based system is quite much more aggregate than the state prior lyophilization. So we have an effect of inulin as auto lyopreservation and cryopreservation, and this is not surprising because inulin, bare inulin, is used in protein technology for this scope, as with the aim to prevent aggregation and to preserve the integrity in the structure of protein in solution after cryo and lyophilization. Analyzing the release of doxorubicin in aqueous medium, we found out that the kinetic of the release can be modulated by changing the core of the nanoparticles. Increasing the molecular weight and the degree of functionalization of polylactic acid onto INU, we can delay the release of doxorubicin up to 30% after 25 hours. Since we are working in a direct our nanosystem against hepatocarcinoma, we tried also to encapsulate the sorafenib tosylate, which is a therapeutic used in the treatment of hepatocarcinoma. And we optimized the procedure to obtain nanoparticle loaded with sorafenib tosylate. And we found out that the best formulation we can obtain is based on the derivative inupla2 with very high drug loading. 14.49% is the maximum we obtained, which is actually an encapsulation efficiency of around 80%. The encapsulated sorafenib was tested for IC50, and we found out that free sorafenib and sorafenib loaded on our nanoparticles have the same potency. So the IC50 is quite the same, while the copolymer alone has not toxic effect on the same cells. We used as a model hepatocarcinoma cells. We tested the toxicity of the copolymer also on red blood cells, and this was done in collaboration with the Polish Academy of Science of Łódź in Poland. And we found out that the copolymer, the results are compliant with the AESTM standard for hemocompatibility. So are we answering to this important question if is inulin natural functionalizable polyethylene glycol? And to do this, I can count on my research group, which is involved in this project, and you can find their name in this last slide. So I thank them very much. And also external collaborator of Institute of Medical Biology of Polish Academy of Science and of University of Naples. And I want also to thank you all for the kind attention. Thank you.